During a solar eclipse, the Earth is plunged into darkness and the Sun's ghostly atmosphere becomes visible. But what exactly causes solar eclipses, and how do scientists create their own artificial solar eclipses, and how will our mission, Probe 3, generate artificial solar eclipses on demand? Let's find out. So, how do solar eclipses happen? The answer is simple. It's when the Sun, Moon and Earth are perfectly aligned and the Moon covers the entire disk of the Sun. The fact that solar eclipses happen at all is a cosmic coincidence. It just so happens that the Sun is 400 times bigger than our Moon, but also 400 times further away, so the two bodies look the same size in our sky. Solar eclipses are extremely valuable because they allow scientists to study the Sun's atmosphere, also known as the solar corona. Scientists are particularly interested in this region of the Sun because it's the source of solar wind and space weather, which can impact satellites and Earth. These effects are especially noticeable during coronal mass ejections, enormous bubbles of superheated gas ejected from the Sun. The solar corona is 1,000,000 times fainter than the Sun's surface, so the light from the solar disk needs to be blocked in order to see it. This is why eclipses are ideal for studying this region, and scientists trek all over the world to see them. Unfortunately though, solar eclipses are a rare phenomenon, occurring only for a few minutes every 18 months or so. But how do we know anything about the solar corona, given that eclipses occur so rarely? Scientists use coronagraphs, special telescopes that use a disk to block the Sun's bright surface. In other words, a coronagraph produces an artificial solar eclipse.
And liftoff of SOHO.
Coronagraphs are not only used on the ground but also in space. Previous Sun-observing missions such as SOHO incorporate coronagraphs to study the corona, but their effectiveness is limited. Mimicking a real solar eclipse is difficult. When using a coronagraph, light spills around the edge of the disk, distorting the view we get. The best way to minimise this spillover stray light is to move the disk further away from the telescope lens. But how much further away? Approximately 150 metres, the length of 1.5 football pitches. And sending something that big into space is just not a practical idea. So how can we create a perfect artificial solar eclipse in space? This is where our upcoming Probe 3 mission comes in. Instead of relying on a single impractically long coronagraph, Probe 3 consists of 2 spacecraft, a camera satellite and a disk satellite. They will fly together so precisely that they will operate like a single coronagraph, around 150 metres long. One spacecraft will block the Sun, creating an artificial eclipse, while the other will observe the Sun. To make this possible, the 2 spacecraft will have to stay positioned with millimetre scale accuracy. Probe 3 will be able to create artificial solar eclipses on demand, significantly advancing our understanding of this mysterious region.